So here we'll learn a process called solving quadratics by completing the square. And in this particular set of problems, it's important to note that the first coefficient, the a term, the coefficient on the x squared term is a 1. So this particular one is x squared minus 10x plus 13 equals 0. In previous sections, you've learned to solve by factoring, but this particular quadratic does not factor. So to learn to solve these, we're first going to look at some ideas here about solving quadratics that have a perfect square already on one side. So a simple one would be x squared is equal to 4. Well, we want to get x by itself, so to undo a square, we simply take the square root of both sides. And since we want both of the roots, we're going to put a plus or a minus on the right-hand side there. So the square root of x squared is simply x, and the square root of 4 is 2, so we get two solutions here. One of them is positive 2, and the other is negative 2. Or you could write that as plus or minus 2. And sure enough, that works. 2 times 2 is 4, and negative 2 times negative 2 is 4. A little bit more complicated if we have a binomial squared on one side that includes the variable. We can use the same process. We take the square root of the left-hand side, take the square root of the right-hand side, remembering to put the plus or minus on it to get both of those roots. On the left-hand side, the square root undoes the square, so we simply get x minus 3. On the right-hand side, we have the square root of 12 plus or minus. We could simplify that to 2 square roots of 3. And again, putting the plus or minus on it. And then finally, now we've got x to the first power on the left-hand side, but we have a minus 3. So if we simply add 3 to both sides, I'm going to put the 3 in front of the plus or minus sign. We arrive at our final answer. So x could be 3 plus 2 square roots of 3 or 3 minus 2 square roots of 3. Finally, this next one doesn't look like a perfect square, but it is. So the first step would be to show it as a perfect square. If I try to factor the left-hand side, I get 2 factors of x plus 3. So indeed, it is a perfect square on the left-hand side. So I rewrite it like that, and then just like in the previous steps, I'm going to take the square root of both sides, remembering, I'll squeeze it in here, my plus or minus sign on the right-hand side. The square root of x plus 3 squared is simply x plus 3. On the right-hand side, the square root of 16 is plus or minus 4. And then finally, I have to subtract 3 from both sides. So I will get plus or minus 4, and then I need to subtract 3. Now you have to remember there's two solutions there, so we've got positive 4 minus 3, which is 1 for a solution, and negative 4 minus 3 is negative 7 for the other solution. And you could go back and plug those in and check them. One thing before we move on to our original problem, it's important that you be able to recognize for a trinomial which ones will factor into these perfect squares. So given x squared plus 2x plus 1, for example, or x squared minus 4x plus 4, or x squared plus 10x plus 25. Can you recognize all of those as ones that will factor into perfect squares? Well, if you notice, if we call, let's see, the coefficient on the x squared term is a, and the coefficient on the x to the first is b, and the constant term is c, what you'll notice is if you take half of the b term, so in the first case, half of 2 is 1, and square it, we get the c term. On the next one, if we take half of negative 4, which is negative 2, and square it, we get 4. And finally, on the last one, if we take half of b, which is 5, and square it, we get 25. That's always going to be the case. So in general, if you take half of b, or b over 2, and square it and end up with c, you know you have a perfect square trinomial. Let's go back to the original problem that we were looking at. This original problem, first of all, does not factor, and let's check to see if it's already a perfect square trinomial. If we take half of negative 10, we get negative 5, but when we square negative 5, we get 25. So this one is not a perfect square trinomial, but with this process, we're going to rewrite it so that it is. So what I'm going to do is, first of all, I'm going to rewrite it, and I'm going to subtract 13 from both sides. So I'll have a negative 13 on the right hand side. And the reason is I want to rewrite this so that that c term is the term that I want in order to have a perfect square trinomial. And that term would be half of negative 10 is negative 5 squared is 25. So I'm going to simply put a plus 25 there. Now you all know that when you have an equation, you can't simply just add 25 to one side without doing it to the other side. Otherwise, you've changed the solution. So I also have to add that 25 to the other side. Now what I've got on the left-hand side is a perfect square trinomial. It will factor into x minus 5. That's half the middle term times x minus 5. But again, I'm going to write it as a perfect square. On the right-hand side, let's see, I've got negative 13 plus 25 is 12. So I've taken something that wasn't a perfect square trinomial and forced it into being one by adding something to both sides. And again, the critical step was I actually took the 13 and subtracted it from both sides first. There is kind of a shortcut where you don't need to do that, but I think this makes the most sense for most people. And now I've got a problem just like the ones before, so let's go ahead and finish it. I simply take the square root of the left-hand side, the square root of the right-hand side, remembering my plus or minus sign. The square root of x minus 5 squared is x minus 5. The square root of 12, if I were to simplify it, is 2 square roots of 3. Again, remembering my plus or minus sign. And then finally, getting x by itself, I want to add 5 to both sides. And I'm going to put the 5 in front of the plus or minus 2 square roots of 3. That is my answer. And again, remember, I actually have two solutions here. If I wanted to write them out, I've got 5 plus 2 square roots of 3 for one answer, and 5 minus 2 square roots of 3 for the other. There you go.